A more advanced application of the complement rule is the probability of at least. For example, a couple has 3 children. What is the probability that the couple had at least one boy? We can solve this directly by listing the sample space. A word of warning here. This is the direct method that is usually not recommended when solving at least type of problem. There are 8 possible outcomes. Boy, boy, boy. The couple has 3 children, which means that they have all 3 boys. Or boy, boy, girl. The first 2 are boys, the third one is girl. Or boy, girl, boy. Or boy, girl, girl. GBB, GBG, GGB, or GGG. If a couple has 3 children, then these are the only possibilities. Notice that each of these outcomes has 3 options: first, second, third. First child, second child, third child. Now, if we're looking for the probability of at least one boy, then this is a compounded event because at least one, meaning that they can have exactly one boy, or they can have exactly 2 boys, or they can have exactly 3 boys. These events are mutually exclusive. Exactly 1 has no intersection with exactly 2 and is at no intersection with exactly 3. The probability of having at least one boy is the same as saying the probability of having one boy, or having 2 boys, or having 3 boys. These 3 simple events, 1 boy, 2 boys, 3 boys, are mutually exclusive. That is why we can just simply add them and subtract 0 because the intersection is 0. They have nothing in common. There are 3 ways to get exactly one boy: BGG, GBG, and GGB. That is, the probability of getting exactly one boy is 3 of these, and each time they have only one boy, which means 1/2. The probability of a boy is 1/2. The probability of a girl is 1/2. And the probability of a girl is also 1/2. We assume that having a boy and girl has a 50-50 chance. Similarly, there are 3 outcomes for exactly 2 boys: BBG, BGB, and GBB. The probability of getting a boy is 1/2, the second boy 1/2, and the third girl 1/2. There's only one way to get exactly 3 boys, and that is boy the first time, boy the second time, boy the third time. Notice that when we multiply these 3 numbers, we actually use independence. That is, having a boy the first time is independent of having the boy the second time and having the girl the third time, and so on. If we add these up, the probability of getting exactly one boy out of 3 children is 0.875. Now, this is the long way to do this problem. A shorter way is to use the complement. We will see that this new method, or the alternative method, is much shorter, and it is a preferred method. If a couple has 3 children, then the sample space, if we were to let x be the number of boys, the sample space is either 0, 1, 2, or 3. they either have 0 boy, or 1 boy, or 2 boys, or 3 boys. How is it possible that they have 0 boy? Well, they have all 3 girls. How is it that they have 1 boy out of 3 children? Well, they either have GBG, GGB, or BGG. Now, the probability of having at least 1 boy is the same thing of asking for the probability of having 1 boy or 2 boys or 3 boys. But notice that the complement of at least 1 is 1 minus the probability of having no boy. This is 1 minus the probability of getting none of the boy is the probability of getting girl the first time, girl the second time, and girl the third time. And having a boy and a girl are independent. So this is a multiplication rule. The probability of GGG is the probability of G times the probability of G times the probability of G. And if we were to do 1 minus 1/2 raised to the third power, we will get 0.875 as well. We should get the same answer, except that using complement, it is much simpler.